I'm excited to be here at the final conference of the Flagship Pilots. As you may know, there are two among the projects which are coordinated by Swiss institutions. We didn't send them into this, but they chose to do that by themselves. And that shows that the flagship concept is married to the bottom-up approach in science, which is typical for Swiss research and good research in general.
Flagships is, of course, a great instrument. It's joining national efforts, trying to avoid duplication in a fragmented Europe, and it's also creating synergy. So it's really ambitious, and I think it will make a great step forward for economy, for employment, and I think also for science.
We want to address a very specific problem, which is a gap that will emerge in the quality of our existence in Europe with the aging of the population. That means we have to support an aging population in remaining active and committed and happy. And we believe this we can only achieve through technology, in particular a technology that exists and can coexist with us, and these are the robot companions.
So the subject of future emerging technologies, and ICT in particular, is of great importance in Israel, both in the academic front in our universities and research institutes, and also being a startup nation on the industrial and commercial level. And so we are very thrilled with this opportunity of being part of a collaboration with European organizations and research institutes on this.
So the Human Brain Project is about the human brain, which is an amazing device. It's one of the big science challenges of the century, and our goals are threefold: to understand the human brain, to understand how it can go wrong, brain diseases, and finally to derive technology that mimic the information processing in the brain.
The graphene revolution started in 2004 in Manchester, when Andrei Geim and Konstantin Novoselov made groundbreaking experiments on this material that has most superlatives of any material that we know of. By combining these superlative properties, we can create a technological edge for many different application areas, such as information and communication technology, material science, and energy applications.
FuturICT is about bringing together social science, ICT and complexity science to bring them together to solve some of the challenges we face today in the 21st century.
So one of the biggest challenges of the project is to develop energy efficient technology. It means reducing the power consumption in computation, in communication, in sensing by 2 or 3 orders of magnitudes. It means that tomorrow we'll have devices that will stay autonomous and will find their energy in the environment without need of using battery or charging these devices from the electrical network. So this is one of our main challenges, to develop this energy efficient type of technologies.
We have technical challenges like the enormous amount of computing power we will need for the medicine of the future. We also have societal challenges because we will have to change the way we develop drugs, the way we do medicines, the way we reimburse treatment to really take full advantage of the new technologies.
I was very much impressed from the beginning when the 6 pilots were selected that we had such a diversity of topics, which I think all topics in itself bear lots of value for Europe. And I must say, in the various visits we had to member states, never the topics were questioned. So everybody more or less supported the range of topics. Now the big challenge comes how to select the 2 out of the 6.